Our next two presenters are Sarah Nelson and Delaney Lantz. Sarah and Delaney will share research today on biological and chemical investigation of Aplysia californica Inc. Their mentor is Dr. Kim Hale. I will turn it over to Sarah and Delaney.
Hi, I'm Delaney Lantz.
And I'm Sarah Nelson, and our mentor for our research this semester was Dr. Kimberly Hale. Today we are going to be discussing the biological and chemical investigation of Aplysia californica Inc. So pictured here is our animal of study that we focused on the past 2 semesters. The Aplysia californica is a saltwater mollusk that can be found on the coast of California as well as the Gulf of California. It is commonly referred to as the sea hare. And pictured here, you can see there are a total of 4 antennae on the head of the Aplysia. 2 are directly above the eyes and 2 are directly above the mouth. And these we will actually discuss in greater detail as we talk about our inking protocol because they are important for our inking protocol. So Dr. Hale's previous research groups and other researchers have actually found that the ink that the Aplysia californica produces has antimicrobial properties. So that is the basis of our investigation for these past 2 semesters, and we wanted to focus on the chemical properties that are actually in the ink that contribute to the antimicrobial properties of the ink, as well as the reasons for various differences in the antimicrobial properties that we have seen in our inks. And listed here are many of the methods that we chose to test our ink with, and we are going to go into greater detail of those in the rest of the presentation.
So we're first going to talk about ink collection and the inking protocol. So when this starts to occur, we move the Aplysia out of their designated tanks. We put them in our inking container, which as you can see here is the aluminum pan. So the first thing we're going to do is stimulate the antennas, and you do this by gently brushing them until their head contracts. After that, we flip the Aplysia between our hands 10 different times. If at this point in time they still have not inked, we then place them in the inking container and put 500 microliters of their instant ocean from their tanks on their bodies. This entire protocol can be performed up to 3 different times, and once it does ink, it is collected and placed in an appropriately labeled tube, and the tube will have the date that it inked and which Aplysia it inked that day. Also, we talk about handling the Aplysia. So daily we'll take the designated Aplysia out of their tanks and place them in the same inking container. As you can see here is the aluminum pan. And just while we take them out and put them in the container, if they ink within that time period, we don't stimulate them or run through our inking protocol. If they happen to ink, it's called spontaneous ink. So the ink is then collected and placed in an appropriate tube, except this time it's labeled with which Aplysia inked, the date, and that it is spontaneous ink. After that's completed, the Aplysia will then be placed back into their tanks. So next we're going to talk about this ink centrifugation protocol. So first we place the 500 microliters of the sample of ink into the appropriate Eppendorf tubes. We place those in the centrifuge. As you can see, this is the lid. It opens up, and then in order to make it balance, the tubes go on opposite sides in order to make sure it spins properly. So we then centrifuge the ink samples at 7,000 RPMs for 30 minutes. Once that is completed, we then strain out the supernatant into a different designated, appropriately labeled tube for the supernatant, and the pellet is left in the tube that it's already in. After this, the samples are then stored in a fridge at 4 degrees Celsius. So here we're going to talk a little bit about the ink components that I kind of mentioned before. The whole ink is the entirety of the ink. So when the Aplysia does ink during our protocol, it's everything, all of the ink collected at that time. The supernatant is going to be the liquid left over after the centrifuge occurs. And then the pellet is going to be the more solid that's left after this. It's what's actually spun down in the centrifuge. So next we're going to talk about IR. What is IR? here is the machine that we use in the organic chemistry lab. So IR is the measurement of the interaction of infrared radiation with matter by absorption, emission, and reflection. It is used to study and identify chemical substances or functional groups in solid, liquid, and gas forms. Why did we use IR? So throughout our research, there was noticeable differences within the antimicrobial properties. So therefore, IR was utilized to determine if the differences in the functional groups correspond with the differences that we found within the antimicrobial properties. So when looking at IR protocol and how this takes place, the machine, as I said before, is in the organic chem lab. So we first turn on the computer that is connected to the IR machine, and then we turn on the IR machine following that. We then go and get the diamond crystal plate, which we then place on the IR machine. We next open the software of OMNIV in order to start the running on the machine. The appropriate plate is selected, and then we click to collect background with no sample added, just to make sure it is completely cleared out before we add a sample. And then after the background is collected with no sample on the plate, we do add a small sample onto the plate, which we then click collect sample, and then we search the library for comparison to other known compounds. And after this, we then print the IR, and we also print the search library results in order to compare to our other ones. And when we click collect background, we do that individually with every ink sample that we have in order to make sure that we are comparing properly. So when looking at zone of inhibition, as you can see here, we do have some antimicrobial growth. So how this starts is we first appropriately label the Mueller-Hinton agar plates with the date and the type of ink and which Aplysia the ink is coming from. We then use small non-gelled plates that also are labeled to match the Mueller-Hinton plates. We use tweezers to place a disc into the smaller plates, which we then put 40 microliters of the ink onto the disc and allow it to absorb for 15 minutes. While that is taking place and the 15 minutes has started, we are using a sterile spreader in order to spread the 3 drops of bacteria onto the Mueller-Hinton plate. After the 15 minutes is up, the disc using tweezers is removed from the smaller plate and added to the Mueller-Hinton plate, which will then sit gel side down for 10 minutes in order for it to fully set into the Mueller-Hinton plate. After those 10 minutes occur, the plates are then flipped and placed on a tray, which is then put in the incubator at 37.5 degrees Celsius. It is approximately in the incubator for 24 hours, and then they are pulled in order to observe and record data.
So after we conducted these different tests on our various ink samples, when we looked at our IR data, we compared them to one another, and we actually found that there were many similarities among our ink samples, but we also noticed that there were some variations. And then when we looked at the zone of inhibition results, we compared them to one another, and we found that the protocol-collected ink actually had a significantly larger zone of inhibition when comparing to the spontaneous inks. So here in this table, we have 4 of the protocol-collected ink samples. All of them had a large zone of inhibition compared to the other samples, ranging from anywhere from 3 millimeters to 7 millimeters, with most of them being in the 6 millimeter or 5 millimeter range. And in the fall, we ran many of our ink samples through IR, and when we compared them, we actually noticed that there were many similar compounds that came up in the library search. And so of those, 4 of these that are highlighted here actually have known antimicrobial properties to them. So we thought that it would be significant for our research if we could actually obtain some of these chemicals and we could do comparative testing to our ink samples. So we were able to obtain 3 of these chemicals. We obtained glyoxyl, glutaric aldehyde, as well as 2-hydroxyhexanediol. So in the spring semester, we took these 3 chemicals and we ran IR on all 3 of them, and pictured here are the results. We used these to compare to our ink samples that we also collected in the fall. And just as we ran IR for the 3 chemicals, we also did zone of inhibition testing for the 3 chemicals. So pictured here are the Mueller-Hinton plates after we went through our protocol, put them in the incubator for 24 hours, and then observed and took measurements. So as you can see here, the disc that actually has the chemical in it was placed in the middle of the plate. And when we take a measurement, we take from that plate to the edge of the bacterial growth. So the plate on the right has a significant zone of inhibition. As you can see that the growth of bacteria is pretty far away from the disc, which does show that it is effectively antimicrobial. And so when we took the zone of inhibition measurements of the 3 chemicals, the glyoxyl had a 17 millimeter zone of inhibition, the glutaric dialdehyde had a 13 millimeter zone of inhibition, but we were actually surprised to see that the 2-hydroxyhexanediol did not have any zone of inhibition. So the Aplysia inks that we wanted to focus on when we were comparing our IR results were the 4 protocol-collected samples that did have a large zone of inhibition that I talked about previously. Those are the L4 whole ink, the L1 whole ink, the L2 whole ink, as well as the L1 supernatant. We also ran many of our spontaneous inks, but they all had very similar results, so we're only going to reference one of those. So this is what we found when we compared the 4 protocol-collected inks. As you can see circled here on the IR results, all of the chemicals that we ran contained an alcohol functional group as well as an amine functional group, but the biggest variation that we found was that the L4 whole ink lacked an alkane functional group, whereas the other 3 did have this functional group. And then when we ran through our 3 chemicals through IR, we actually found that glyoxyl was the only one that contained this alkane functional group. And then when we looked at our spontaneous collected inks, we went ahead and used the iSpontaneous pellet to go ahead and just show the results that were similar among most of our spontaneous pellet. And here it is also lacking the alkane functional group.
So when looking at some future studies, we thought it would be really interesting to do the NMR instead of just IR. NMR is used to study the physical, chemical, and biological properties of matter. Where IR only allows us to see certain functional groups, NMR can help see the entirety of the organic compound. Also, as you can see, we are also looking to further analyze the ink, such as the whole ink, the supernatant, and the pellet, and just continue that research. We are also going to continue the same tests, but also focusing on other factors that could influence the antimicrobial growth that we're dealing with, such as Aplysia age, health, number of inkings, and even the storage of the ink. Some acknowledgements we would like to make are to the chemistry department and Dr. Deskin specifically for allowing us to use IR and helping us understand it even more in order to further our research. And we would also like to thank Dr. Hale's research group for helping conduct research throughout the entire semester. Thank you. We'll be taking questions.
So I have a really basic 2-part question. Why does a little critter want to ink? Does he want to ink? And my second part, is this similar to annoying a skunk on the road? I mean, what is the biological purpose of the inking? I understand what you're going after with the antimicrobial issues and that sort of thing, but you're evidently forcing the little guy to do it, so some background on that would be interesting.
Yeah, so the inking that occurs is actually a defense mechanism that the Aplysia has, so that's why, especially when we stimulate them during our protocol, that's just them trying to defend themselves against us.
Just out of curiosity, how many Aplysia did you guys ink during your research?
So it varied between the 2 semesters. We did actually, that's another thing that could have potentially influenced some of the data. Occasionally throughout the semesters we did have a couple Aplysia die, so that the number of Aplysia that we were actually testing and inking throughout the semester greatly varied from week to week.
So from the studies that you've done so far, do you have any indication as to what type of organic molecule your antimicrobial agent may be?
We don't have a specific compound. I think we're getting closer to that, though, and as we continue into next semester, we're definitely going to get closer to finding that.
Thank you, Sarah and Delaney. We'll take a short 10-minute break, and then we will be back for a couple of business presentations. Thank you.